Right now in the silent desert of California, a weapon that can think for itself is already in the sky. It doesn't show up on radar. It doesn't miss. And by the time the enemy even realizes it's there, it's already gone. The B-21 Raider isn't just a bomber. It's the ghost that will define the next 100 years of American air power. I remember the night the operations center lit up like a starfield, and the intel stream began to hum. Another B-21 had flown. For those of us who think in knots and hull numbers, the details landed like a salvo. On September 11, 2025, the second B-21 Raider rose from Palmdale and joined the test program at Edwards Air Force Base. That date matters less as an anniversary than as a milestone. This airframe had already been rehearsed hundreds of times in a virtual world before it ever felt gravity. Engineers ran the aircraft in a digital twin environment, executing more than 200 simulated flights that added up to over 1,000 virtual flight hours before the first physical prototype left the runway. For sailors and aviators who respect rigorous testing, that is the kind of preparation that changes risk calculus. You can debate doctrine, budgets, and headlines, but certain facts change operational calculus. Nearly 40 B-21s are in various stages of production now, and planners are quietly considering expanding the buy from the original plan toward 145 units. The unit cost lands around $800 million apiece, a headline-grabbing figure, sure, but cheaper than some legacy platforms and calibrated against a radically different value proposition. This is not a bomber you buy simply to drop bombs. It is a networked, software-defined asset whose operational worth is measured in its ability to shape the decision space across services. If this made you proud of what American innovation can do, hit that like button and subscribe for more stories from the front lines of technology and defense. Tell us in the comments, what do you think the B-21 Raider means for the future of air power? Your thoughts keep this community flying. From the perspective of ships and sailors, the B-21's most consequential attributes are not raw speed or stealth signature alone, but its ability to fuse sensors and to act as a battle manager in the sky. Multi-sensor fusion, the capability to merge radar, infrared, electronic warfare systems, and passive detections into a single coherent picture, gives decision makers a common operating picture richer than anything most fleets currently rely on. In literal clashes, contested amphibious operations, or strikes to suppress anti-access area denial networks, that fused picture compresses timelines and clarifies risk. When a destroyer captain receives a targeting product that has already been cleaned, correlated, and prioritized by a high-fidelity airborne node, the time from detection to engagement shortens dramatically. The digital-first engineering model matters too. The B-21 was designed to be updated, not retired. Open systems architecture means that new weapons, improved electronic warfare suites, or better radar processing arrive as software updates, comparable to pushing new features to a smartphone. That approach collapses upgrade timelines and reduces the logistical friction of fielding capability enhancements. For naval planners used to multi-year retrofit cycles and crowded shipyard schedules, this is a force multiplier. When software becomes the primary vector for capability growth, islands of hardware obsolescence shrink. Equally important is the way the B-21 has been developed. The digital twin environment allowed engineering teams to iterate thousands of times in virtual space, to test software patches, avionics changes, and mission packages with far less risk, and to validate performance before hardware modifications were committed. When something goes wrong at sea, we do not have the luxury of an extended rework window without exposing ships and crews. Platforms that can be matured and hardened in the cloud before physical modifications are attempted reduce operational downtime and increase sortie availability across the joint force. The airframe's AI is another inflection point. This is not an assistant that schedules meetings. It's a combat system that processes sensor streams and presents distilled, prioritized options to the crew. Imagine a strike package steaming toward a contested archipelago while shore-based air defenses, mobile missile launchers, and adversary fighters contest the air. The B-21's onboard AI sifts through competing signals and recommends tactics, route adjustments, jamming profiles, countermeasures, and timing windows for coordinated effects. the system reduces cognitive load by filtering thousands of low-value alerts into a succinct set of recommended actions, allowing mission commanders to focus on the strategic picture rather than getting buried in telemetry. Importantly, the B-21 does not replace human judgment. Commanders retain authority over lethal choices, especially in nuclear contexts. The aircraft is dual-capable. While its software can assess and present options with unprecedented rapidity, the final decision, especially concerning strategic nuclear employment, remains a human one. That principle is a cornerstone for interoperability and for maintaining political and ethical control over the use of force. AI amplifies operational tempo, but does not absolve the chain of command of responsibility. Part 2. Integrating the radar into maritime strategy. When we think about integrating a platform like the B-21 into maritime operations, the focus shifts from individual sorties to synergy across domains. The radar is most potent when it acts as a node that bridges space, air, sea, and cyber. It can collect signals intelligence, process that information in near real time, and share actionable products with strike groups, carrier strike commanders, and expeditionary forces ashore. That capability transforms a carrier group or amphibious ready group's available options. Ships can operate from more advantageous positions when they know which threats have been suppressed or deceived, and when their sensors are being cued by an invisible hand overhead. The manned-unmanned teaming concept remains central to this evolution. Although plans for a dedicated B-21 drone wingman were shelved in 2022 for cost reasons, the radar's architecture allows it to coordinate with existing unmanned systems. Loyal wingmen or long-endurance drones can probe air defenses, draw fire, or carry specialized sensors or munitions, while the manned bomber executes higher-level mission tasks. In a maritime environment, drones could feed persistent imagery, extend electronic warfare envelopes, or serve as expendable probes, enabling surface and subsurface units to task weapons with greater confidence and less exposure. From a naval logistics and training viewpoint, the B-21's software-centric upgrade path simplifies lifecycle management, but also requires a cultural shift. Sailors and officers must be proficient in cross-domain data handling, cyber-safe update workflows, and rapid integration testing. The sustainment model shifts from depot-based hardware swaps to continuous software integration and verification. Shore infrastructure, secure communications links, and hardened cloud facilities become as essential as munitions and fuel. Forward logistics nodes will need specialized teams capable of validating and deploying vetted software updates while ensuring operational security. The psychological effect of an unseen, precise, and network strike capability should not be underestimated. For adversary operators tasked with protecting fixed sites or maritime choke points, the uncertainty of not knowing when or how a B-21 might appear, combined with its ability to suppress, deceive, or strike, imposes operational stress. That friction can shape enemy decision-making in predictable ways, degrading their tempo and cohesion, and creating windows for friendly maneuver that did not exist before. Nevertheless, mastering this capability requires hard work. The Navy must invest in joint exercises that emphasize data sharing, command and control resilience, and interoperability under contested conditions. Practicing OODA cycles with AI-augmented inputs changes the rhythm of command. Staff processes must adapt to receive prioritized recommendations rather than raw telemetry streams. Doctrine must be updated to account for a platform that can be upgraded continuously and integrated into distributed lethal and non-lethal effects. Rules of engagement, legal reviews, and ethical training must stay current so that velocity of decision does not outpace accountability. The cost calculus also deserves scrutiny. An $800 million airframe is expensive on paper, but when evaluated as a persistent node of an integrated force, the per-mission value can shift the conversation. If a single B-21 sortie can enable a carrier strike to operate with reduced risk, direct naval platforms to higher-value targets, or protect amphibious operations through superior intelligence and timing, the strategic return on investment becomes clearer. Scaling production toward 145 units would increase redundancy, lower scheduling bottlenecks, and expand the range of coordinated effects available to joint planners. Consider a notional operation in which a carrier strike group must operate inside an adversary's anti-access bubble. Traditional sequencing, softening defenses, sending strike packages, accepting risk to manned platforms becomes more hazardous as sensors and missiles proliferate. With a B-21 acting as a stealthy sensor shooter and airborne battle manager, the latter flattens. The bomber can infiltrate denied airspace, map emissions, and provide prioritized targeting that allows ships to maneuver with greater safety. Electronic warfare is baked into that vision. The Raider's architecture supports coordinated jamming profiles, adaptive decoy deployment, and waveform management that complicates enemy tracking. As detection technologies evolve, the B-21's open systems approach means countermeasures can be inserted rapidly via secure software updates. In effect, a new defensive capability delivered over the air instead of through protracted hardware retrofits. Operationally, naval forces must also reckon with dependencies. The Raider's effectiveness depends on resilient communications, satellite links, and secure cloud environments. If those links are contested, commanders need robust fallback modes and doctrine for degraded operations. That is why joint exercises must practice partial information scenarios, where crews learn to harmonize autonomous recommendations with human-led decisions in the face of intermittent connectivity. The logistics and workforce implications are significant. Producing nearly 40 airframes now and planning for as many as 145 requires steady supply chains and a new sustainment mindset. Building that industrial base and aligning forward maintenance with software sustainment demands new training pipelines and cross-domain liaison roles that blend maritime operations with airborne systems engineering. Training, doctrine, and legal frameworks are equally vital. Accelerating the UTA loop with AI-assisted inputs reshapes command tempos. Staff processes must shift from consuming raw telemetry to acting on prioritized AI-curated recommendations. Rules of engagement and legal reviews must keep pace so that faster decision rhythms do not erode accountability or lawful control over force. Crucially, decisions with strategic consequence, especially nuclear employment, remain under human authority. The system must preserve that boundary. Strategically, the psychological effect of a stealthy, network strike capability should not be understated. An adversary uncertain about where a precision strike might originate and unsure whether assets will be jammed or deceived, faces operational friction that can deter aggression. To sustain advantage, the U.S. must pair capability with doctrine and allied integration. Routinely exercising the Raider in joint training, demonstrating upgrade cycles transparently to partners, and aligning tactics with allies. In short, the B-21 Raider is as much an organizational and doctrinal inflection as it is an engineering accomplishment. Built with a digital twin validated by over 200 simulated flights and more than 1,000 virtual flight hours, with nearly 40 airframes in production and the option to expand toward 145 and priced roughly at $800 million apiece, it shifts the calculus from isolated platforms to network nodes. For sailors, Marines, and joint planners, the immediate task is clear: adapt our procedures, train for degraded and contested environments, and institutionalize the cross-domain habits that convert digital advantage into real-world superiority. This requires sustained funding, deliberate planning, and inter-service humility. Today,